In this episode, we are going to talk about bias in AI in a way that is clear, practical, and grounded, because the word bias can make beginners feel like they have to choose between being technical and being ethical, when in reality you need both. Bias in AI is not only about bad intentions. It is often about data and design choices that accidentally create unequal outcomes. People sometimes assume that because an AI system uses math, it must be objective, but the system learns patterns from data that reflects human decisions and real-world inequality. Detecting and reducing bias means you first learn how bias enters, then you learn how to measure it, and then you learn how to choose trade-offs that are fair enough for the purpose without pretending perfection is possible. The title emphasizes three ideas we will focus on: representation, measurement, and fairness trade-offs. Representation is about who and what is included in the data and the use case. Measurement is about what you choose to measure and how those measures can distort reality, and fairness trade-offs are about how different goals can conflict. By the end, you should be able to explain why bias can appear even when nobody is trying to be unfair, and you should understand why fairness work is a continuous discipline, not a one-time check. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to define bias for beginners is to say bias is a systematic pattern that produces unfair or unequal outcomes for certain people or groups, especially when those outcomes cannot be justified by the system's purpose. That definition matters because it separates random error from consistent harm. An AI system that is equally unreliable for everyone is a quality problem, but a system that is reliable for one group and unreliable for another is both a quality problem and a fairness problem. Bias can show up in many places, including the data used to train the system, the labels that define what correct means, and the way outputs are used in decision-making. Bias can also show up in the environment, such as when some users have better access to resources that help them benefit from the system, while others are left behind. Beginners sometimes think bias is only about protected categories, but bias can also appear across other meaningful distinctions, like language ability, disability, region, or socioeconomic context. Detecting bias requires you to ask who might be harmed and how, not only who is in the dataset. Reducing bias requires you to design controls that keep the system aligned with fairness goals and with the organization's responsibilities. Representation is the first major source of bias, and it is about whether the dataset and the testing process reflect the real people and situations the system will affect. If a dataset mostly represents one type of user, the model will tend to learn patterns that work best for that group. This can happen even with large datasets, because size does not guarantee diversity or coverage. Representation also includes the range of contexts, like different writing styles, different dialects, different device conditions, and different behaviors, because those factors can influence performance. A beginner-friendly example is speech recognition, where models trained mostly on certain accents may perform worse for others, which becomes a fairness issue if the system is used for important tasks. Representation problems can also happen when data is collected from convenient sources, like early adopters, which can skew the dataset toward people who already have more resources or technical comfort. Detecting representation bias means comparing who is in the data to who will be affected in real use, and noticing missing or underrepresented groups and situations. Reducing representation bias often requires deliberate collection strategies, not just passively accepting what data happens to be available. Representation also shows up in labeling, because even if you have diverse data, you can still encode bias if labelers interpret behavior differently for different groups. For example, if a support message written in a direct style is labeled as aggressive while similar content in a different style is labeled as neutral, the model will learn a biased pattern that penalizes certain communication norms. Another representation issue is that some groups may have fewer recorded outcomes, such as fewer follow-ups or fewer opportunities to provide feedback, which means the dataset captures their experience less clearly. This is an important beginner point because it shows that bias is not always visible in the raw data. It can be created by how the data is interpreted and categorized. Another subtle representation problem is survivorship, where the data reflects only those who stayed in the system and not those who left because of poor experiences. If people disengage due to unfair outcomes, their absence makes the dataset look better than reality. Detecting this requires curiosity about who is missing and why. Reducing it may require adding feedback loops that actively seek signals from those who are not well served. Measurement is the second major source of bias, and it can be harder for beginners because it is about what you choose to measure and how that choice shapes outcomes. Many AI systems use proxies, meaning they measure something easy and treat it as if it represents something important. For example, a system might measure past approvals as a proxy for merit, but past approvals can reflect historical bias, so the proxy bakes bias into the model. A system might measure customer satisfaction as a proxy for quality, but satisfaction can depend on factors unrelated to fairness, and some groups may be less likely to submit feedback. Measurement bias can also happen when the same metric means different things for different groups, such as a certain behavior being interpreted as riskier for one group than another. Beginners often assume metrics are neutral because numbers feel objective, but measurement choices are human choices. Detecting measurement bias means asking whether the metric truly captures what you care about and whether it behaves consistently across contexts. Reducing measurement bias often requires redesigning metrics, adding additional measures, or acknowledging limitations instead of pretending a single number captures fairness. A simple way to make measurement bias feel real is to consider how labels are often created from past decisions, and past decisions can be flawed. If an organization has historically escalated certain complaints more often based on stereotypes or assumptions, then escalation history becomes a biased label that teaches the model to repeat that pattern. Even if the model is accurate in predicting past escalations, it is not necessarily fair or correct in terms of what should happen. This is a crucial beginner insight because it shows that accuracy is not the same as fairness. A system can be accurate at predicting biased outcomes, which means it can automate injustice with high reliability. Detecting this requires separating descriptive goals from normative goals, meaning you ask whether you are trying to predict what happened or guide what should happen. Reducing this kind of bias may require relabeling, using different outcome definitions, or adding human review for sensitive decisions. This also connects back to the earlier topic of data quality, because accuracy and labeling quality can hide fairness problems when the labels reflect biased history. Measurement is where fairness becomes a question about values and purpose, not just technical performance. Now we arrive at fairness trade-offs, which is the part that often confuses beginners because it sounds like a compromise with justice. The reality is that fairness has multiple definitions, and improving one definition can sometimes worsen another, especially when groups have different underlying conditions or different rates of certain outcomes. For example, you might try to make error rates equal across groups, but doing so could change decision thresholds and affect who receives certain opportunities. You might try to ensure equal approval rates, but that could conflict with a goal of equal error rates if the data distribution differs. The goal is not to memorize fairness formulas. The goal is to understand that fairness is not a single switch you turn on. A fairness trade-off exists when two desirable goals cannot both be maximized at the same time under the current conditions. Detecting fairness trade-offs means being honest about what fairness goal you are prioritizing and why. And reducing harm means choosing a goal that fits the system's purpose and the organization's responsibilities. Beginners should hear this as a call for transparency, not as permission to ignore fairness. Trade-offs also show up between fairness and other objectives like privacy, security, and usability. For example, collecting more demographic data can help detect bias, but it can also increase privacy risk if handled poorly. Adding strict controls might reduce misuse, but it might also reduce access for certain users if the controls create barriers. Optimizing for the highest overall accuracy might improve performance for the majority while leaving minority groups with worse performance, which can be unfair even if the average looks good. Another trade-off is between explainability and performance, where some highly accurate approaches may be harder to explain, which can complicate accountability. Beginners often want a rule that says fairness always comes first, but real systems require balanced decisions with clear reasoning. The The critical skill is not avoiding trade-offs. It is making them explicit and choosing them deliberately rather than accidentally. Detecting and reducing bias includes asking what trade-offs are being made silently, because silent trade-offs usually benefit the powerful and harm the vulnerable. When trade-offs are explicit, they can be discussed, tested, and improved. Detecting bias in practice often begins with simple comparisons that reveal uneven performance, even before you dive into complex analysis. You can compare error patterns, such as where the system makes wrong predictions, produces unsafe outputs, or fails to understand certain language styles. You can compare user experiences, such as who reports frustration, who stops using the system, or who is consistently routed to worse outcomes. You can also compare how the system behaves under different contexts, such as noisy inputs, shorter messages, or non-standard phrasing. Bias detection is not only about statistics. It is also about listening to user signals and recognizing that some users may be less likely to report problems. That is why detection should include proactive checks rather than waiting for complaints. Another beginner-friendly idea is that bias detection requires clear definitions of harm, because you need to know what outcomes matter. If harm is defined vaguely, detection becomes vague, and vague detection does not prevent harm. When you design detection around meaningful outcomes, you can see patterns that point to representation or measurement problems. Reducing bias is not a single fix. It is usually a combination of data improvements, design constraints, and monitoring. Improving representation might involve collecting better data, balancing datasets, or ensuring test sets include underrepresented scenarios. Improving measurement might involve redefining labels, using better proxies, or adding additional signals that reduce distortion. Design constraints might involve limiting how outputs are used, adding human oversight for high-impact decisions, or avoiding automation where fairness cannot be assured. Another important bias reduction tool is transparency in the user experience, because users can correct errors and provide feedback when they understand limitations. Monitoring is essential because fairness can drift as data and user behavior change over time. Beginners should remember that a system can be fairer at launch and then become less fair later if the environment changes. Reducing bias is therefore a continuous process tied to lifecycle management, not a one-time certification. When organizations treat bias work as continuous, they create room for learning and improvement rather than pretending the system is perfect. A misconception that needs to be corrected is the idea that bias reduction always means making outcomes equal for all groups in all situations. Sometimes equal outcomes are not appropriate because groups may have different needs or different contexts, and forcing equality can create new harms. The goal is to reduce unjustified disparities and to ensure the system's behavior can be justified by purpose and values. Another misconception is that bias is only a data problem, when in reality bias can also be created by how the system is deployed, such as when users interpret outputs differently or when the system is integrated into a process that already contains inequality. Another misconception is that fairness is purely technical and can be solved by engineers alone, when in reality fairness decisions reflect organizational values and must involve governance. Beginners should take away that fairness work is multidisciplinary because it includes data, design, policy, and accountability. When you reduce bias effectively, you build trust and reduce the risk of harm, but you also strengthen the system's reliability because fair systems are often better tested and better understood. Bias reduction is therefore part of quality, not separate from it. As we close, detecting and reducing bias is about understanding where unequal outcomes come from and building controls that prevent those outcomes from becoming automated harm. Representation bias asks whether the data and testing reflect the people and context the system will affect, and it reminds you that missing coverage can hide failure until it is too late. Measurement bias asks whether your metrics and labels truly represent what you care about, and it warns you that accurate prediction of past decisions can still be unfair. Fairness trade-offs remind you that there are multiple fairness goals and that improving one can affect another, which means fairness must be chosen deliberately and transparently. For brand new learners, the key takeaway is that bias is rarely solved by a single clever technique. It is reduced through disciplined data practices, thoughtful design, and continuous monitoring. When you can explain these ideas clearly and recognize the trade-offs, You are building the kind of judgment that responsible AI risk management requires, especially in Domain 3, where data and lifecycle control shape real-world impact.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.